Okay, we're gonna do a little video here. I am going to take apart this ion and show you what I did to it. So this is a ion that I've been working on for, well, I guess literally, what, like over 15 years now. The main part of it is this Deadlywind Foehn 2.0 body, which I had anodized by Arc Anodizing. Some of the other stuff going on outside of it. I got this custom products rail and ASAG that makes the tank sit a little bit lower so that when it's on my shoulder, the back of the gun is at my nose level and I don't have to bend my neck. Custom products feedneck, custom products sling trigger that has a spring instead of a magnet. These things are kind of a bitch to install, but I like the feel of it. Although the magnet triggers are fine. And actually the stock ion trigger is fine. But I'm using this one because I got it anodized. I've got the stock regulator on it. Stock regulator is perfectly fine. I keep hearing, I've heard it for years about how it's garbage, it's trash. I was just shooting with it today and was getting great consistency at 10 balls per second. Maybe you can't shoot faster or consistent faster than that, but it works fine. Stock frame, which works the best for ions. I've tried different frames and they're either hard to find and expensive, or they've got weird milling that makes it hard to fit certain parts in, and the stock frames are really cheap and plentiful. If they ever get banged up, you can find a nice looking one for like 20 bucks. And I've got the soft touch, or what do they call it? Pro Touch soft grips. And this gun, you'll see it is we'll take a look at the Lucky Spitfire board, which is less well known than the Virtue board, but actually works really great and has all the same or better features in some cases, I think, than the Virtue board. It's definitely a little bit more rugged, I've discovered, because I've already wrecked like 3 Virtue boards over the years. And this one also has the advantage of having a button harness or a button pad that works in the back. And I actually was able to figure out, because one of the Lucky Spitfire boards that I got came with the remnants, or it did come with, I think, the actual harness, but no pad. So I was able to get it to work, and I was able to, make some parts for it. So also, just a couple other notes I've got, well, just one more note. I've got this gloss breech on the front of it instead of the stock sort of powder-coated breech, because it's shiny and it makes it look nice and matches sort of the gloss finish. And I've got the Epiphany button, which actually is not functional because of the way the Lucky frame works, but that's okay because I just use the button pad. But the Epiphany button lets me see the colors on the board LED better, so that I can tell what it's on and what mode it's on and so forth. All right, so what I'm going to do here is I'm just going to remove the bolt first. Oh, and also I have the gauge on there, so that you always got to have the smart parts gauge so that you can see what pressure you're running. On this particular gun, sometimes I don't have the middle bolt under the frame here by the trigger guard, but on this gun I do have it, because you'll see that I need it to kind of hold the gun together when it's put together. All right, so this is a semi-bob body, which means that I can take the bolt out the back. And it's semi-bob because I can't just slide it out like on like on modern guns. Every modern gun can do that. You have to remove a bolt like guns did back in the day. All right, and the other thing about these ions is that you need to have a deep well socket. Well, it's not deep well, but 5/8 wrench or socket wrench like this to get the bolt out the back. So on this particular gun, I've got a Shocktech dual O-ring bolt. And what the dual O-rings do is make the gun more efficient, because it cuts off the flow in the forward firing position. You see this little hole right here. When the bolt's all the way forward, the second O-ring at the front here cuts off the airflow, so that you're not just shooting air down your barrel after the ball's already left the barrel. And of course the rear O-ring seals off the back, so you don't get a leak when it's firing. These Shocktech bolts are still available in anno gear if you need one for a mech ion. And they're all right. You know, I actually had a bunch of stock bolts milled for second O-ring. If you guys need one, hit me up. All right, so now we're going to get into it. What I'm going to do is I'm going to take off the front bolt, and then we'll start to see the magic happen here. Now this ion doesn't look like any other ion that I own. I have like 7 now because I'm weird like that. I'm going to take off the grip so I can get the electronics out. And just move that out of the way. Now you can see the first thing you're going to notice here is that I am not using the stock solenoid. I'm using a Mac 33 solenoid, which is something I've heard about for years. And I finally, someone on, this guy on Facebook is selling them. I will get his name later or link to it. I don't remember it at the moment. Sorry, dude. But what you're going to see here is I'm not using any of the stock tubing. I do have to disconnect the button pad. So I disconnect that. The whole thing comes out. So because I'm using the Mac 3 solenoid, Mac 33, and you can see it right there, which actually it turns out is the same brand that makes the LV1 through and 1 and 1.1 and 1.5 solenoids that were on those guns. Those were also, I found a press release that Mac made those. But what I did is, using some soldering wick and a soldering iron, I removed the stock solenoid, whatever you want to call it. I don't know if it's the body, from the back of this Lucky Spitfire board. I previously had changed out the capacitor because on a lot of the, all the ion boards now, the capacitors are going on, 15 years old, and that's about the end of life for those things. Even if they're just sitting there over the years, the aluminum and the whatever material in there is going to break down and lose its capacitance. So I just went ahead and ordered off of Mouser.com some new capacitors that are the same spec. It's a 2200 UF micro, whatever that is, and 16 volt. That's what you use. I can't remember what the micro F is on there, but you'll see that printed on the Zongas made in Taiwan capacitors. This one is a Nichicon capacitor made in Japan. I've also used Rubicon and Panasonic, and I think Rubicon are the best, but you probably don't really notice a difference. But you will see if you have an ion board where there's just insane drop off when you start firing more than 5 shots per second. It could be the capacitor's gone dead, and you can just replace that. You have to remove the solenoid body, and then you remove the capacitor, and then you put a new capacitor on, and make sure that you've got the negative terminal on the negative side. You can see the little negative symbol there, and it should be marked on here which side is the negative side, or you can figure it out by looking at the wiring for the battery if you have a stock ion board. But yeah, so in this case, I put on a capacitor, and then I found this guy selling these Mac solenoids, and what you got to do is you just, if you can see right there, it has these 2 long wires. They're not polarized or whatever, so there's not a negative and a positive end, and you just plug them in to the bottom two little mounting points for the old solenoid. And you probably, in this case, I had to trim off some of the length there because it was about 3 times as long as this wire. Put it on there, give it a little slack so it's less likely to break, and it works. So what is the advantage to using the Mac solenoid? I'm not really sure that there is that big a difference, although I was test shooting this gun today at the field. I shot a hopper through it, and I was hitting between 280 and 290 with no drop off at 10 balls a second, which is really good, because what I've noticed with the stock ion solenoids, in some cases, I'll get drop off about 20 FPS, and you don't notice it unless you've got a virtue clock that can show you shot to shot what you're shooting in a string. So if you go on ZDPS or whatever, ZDSPB, I think, there's a section on there that talks about solenoid design. And what's different about these solenoids is that, like most of the solenoids you'll find in high-end paintball guns, instead of there being a piston on it, like if I just get out like a stock, one of my bazillion stock Ion boards, and I'm gonna plug in the battery, and what happens is you turn it on. This one has got a Rubicon ZLJ 16 volt 2020 or 2200 micro F capacitor on it. I also modified this one. You put new button switches on. Oops, I just changed the settings on it. All right, well, whatever. Oops, dang it. I'm an idiot. Okay. If we open this sucker up, and there doesn't happen to be a clip on this, I need to put one on there, but you'll see that the solenoid piston, and this is one of the Keon DOS solenoid pistons that make these guns usable again, but you can see that, I don't know if you can see that, you've got this whole armature, and the whole thing is moving when you activate this electromagnet. It's basically what you've made here is an electromagnet, and by activating it with a switch, it's putting voltage into the electromagnet and energizes it, and it causes this little piston to move, right? In the case of these guys, there is a piston, but there's also the separate, instead of surrounding the piston and moving this whole heavy armature, and you can see this thing, I mean, it's got weight to it. There's the smaller piston spool, like a little spool like you'll see if you ever open up a Shocker SFT or NXT, and there's the separate electromagnet down here, and when you activate it, it moves, the electromagnet is pushing the spool instead of making the whole armature jump. So I guess the theory is, if I remember from what I read, that it's easier for this thing to keep moving the spool than it is for the stock Ion board to move this really heavy armature. So what happens is you're putting someone out there who's an electrician or does electrical engineering can correct me on this, but my understanding at a very, very basic level is that, you know, you're getting a certain amount of voltage from these 9-volt batteries, and when you are drawing voltage from this battery, the very first jump you'll see is, the very first shot on a stock Ion board is going to be, have that full voltage moving this heavy armature. But then as you're putting more load on the battery, the battery voltage drops, and then the second and third shot after that, especially as you start rapid firing, less energy going into the board from the battery, and therefore it's not opening or staying open as long as it could, which is why you start to see this drop off. And it's not noticeable, back in the day, you don't really notice a drop from 280 to 260 just with the naked eye. You'll notice a drop from like 280. If you've got a real problem, you'll see a drop to like 240 or 220, which you can see happen if you've got your gun set, if you've got the dwell too low. But the effect is basically the dwell lowers as the battery's firing or being drained and the stock board is firing. And the theory, at least for the Mac 33, is because it's requiring less voltage to move that spool, it's going to not put as much load on the battery, and therefore you can sustain that dwell as the spool is moving back and forth. You're not going to have as much drop off or any drop off, which is what I saw today. So that's what I think's going on. Yeah, so the other thing that's going on here is that because you don't have this, the head of the solenoid that you've got here that's held together by a clip. I need to dig one out, put one on here. You've got your solenoid, you've got your clip. You want to make sure you have a clip that's not magnetized. I have like 10 of these things, and I only have 3 left that I'm not using that aren't magnetized. And there's a really simple test for that. If I can show you, if you take it and you against your steel armature and you put it on there, it's not gonna pick it up. But if I have one that is magnetized, and the gun might work still, but you know, you can see maybe that it's connecting, and so I don't want to use this armature. So these are gonna go in the recycling bin. This one does not have any sort of whatchamacallit magnetized. It's not magnetized. So I can safely use that. And I should also note that one neat thing about these Ion boards, the stock ones, is that some of them, like this one, do have the instant on. Look at that. Just like the Virtue boards, instant on. Bam, it's on. All right. The older Ion boards do not have that. Okay, so I can't use that head on that from the stock Ion board because I'm not using the same Ion solenoid. So what I had to do is I had to get, you know, these little barbs like you'd find in an Intimidator, or maybe some certain autococker rams, you know, barbs that you find inside these pneumatic paintball guns. This one has a couple barbs because it's the bolt-out back body has the barb on the back of it, so that the air will go between these 2 O-rings and then go into the donut where the donut would be, and go into the back of the can that powers the paintball to fly down and hit my opponent. So what I did was I had to swear a lot, but I happened to have a ton of this tubing, and I have these junctions, T-junctions, that I used to build mechanical ions in the past. And so I had one of those lying around, and I found a way to route the tube so that the bottom here goes to the back of the solenoid. There's 2 holes on the Mac 33. You want to use the top one. The bottom one's to vent air when the spool moves. And then on the front you have, in this, it's a 3-way switch. And then so you have this tube, this barb with a tube that goes to the front of your breech to hold or the middle hole to hold the bolt back in the back position. And then of course when you energize, it switches and it cuts off the supply. So you can see that you've got the electromagnet is actually down here. The spool's up here. Normally the spool is pushed down by the air. When it's aired up, the air is going into here, pushing the spool down. When I activate the electromagnet, it pushes up the spool, cuts off the air supply to the front. The air comes and rushes out. It would normally rush out through this hole right here, but I've got a 360 QEV, so it's gonna come out somewhere down here and get grease everywhere, which you can probably see on the can, maybe. Nope, it's not there. Fires the paintball, the bolt moves forward, fires the paintball, and then it de-energizes and everything resets. That's basically it. And a couple notes here. So I do more notes. I have the way that I got this to fit is I had to cut this tubing to a length where it loops around. If you try to go straight to have it like if it's up like this, what's going to happen is that your tubing is going to cut off at such a sharp angle that it's going to pinch. And you may not get enough air to set your bolt, but it just so happens that the way this fits in is that there's just enough air supply going here to energize going through this loop to push down the spool, and it works. I did also have to try to find a place to put the T-junction. I can't put it back here, like I can't put it directly over this little 90-degree barb, which I use just because I happen to have it, and also it also helps me not have the tubing have to do a 180-degree turn. Now it only has to do like a 45-degree turn, which means that the tubing is less likely to get pinched and cut off air supply, which would cause my bolt to shoot forward because there'd be no air pushing it back. But by doing this, putting it right here, that gives me enough space that I'm able to fit the tubing in this little cavity right here. I don't know if you can see that, but the cavity right here underneath where the 360 QEV is, you've got your solenoid right here, the 360 QEV right here, and that leaves plenty of space right here for the tubing to fit in. And you have to be careful. If you cut the tubing too long, it's going to push against the top of your trigger, and you're going to feel your trigger not go back and forth. So you have to get it not too short that it makes a right angle and cuts off the air supply, but not too long that you're going to have extra tubing that pushes into your trigger. And you may have to, when you're putting this together, I had to try a couple times to get it all fit, but eventually it did. The other thing is, the reason why I have to have this bolt in the middle here is that it just gives a little extra, precaution that I'm not going to have this tubing pushing on the top of the Ion and pushing the body apart. So it just holds it all nice and snug together. The final note for installing this thing is that you've got these two wires. So the way that I route that is, you just have this cutout right here that's perfect on the Lucky Spitfire board to fit the front barb. But then you've got these two wires, and what you've got to do is, again, you want to cut them long enough so you have some slack and you're not at a risk of breaking anything or it falling, you just have some slack to resist tugging on it by accident or whatnot. But you also want to make sure you route these wires so that they don't go in front of the trigger switch. So if you put the wires in wrong, you could have the wire in front of the trigger switch and it'll be pushing it down or make it not, or maybe it gets stuck behind it and you can't actually activate your trigger. So that's the other thing. I put this, the wires through the through the front here because there's less mess. Like there's this capacitor, there's some diodes and shit right here. And I did not, I'm not the best at soldering. Can only do really basic stuff, but you want to keep as far away when you're soldering as possible from any of this stuff going on here. If you get solder on your chip, you will have a dead board. And same for any of these little diodes and resistors and capacitors and all this bullshit that's here. You have to be really careful. I use a soldering wick again, and I actually put the board in a vice clamp that I have on my workshop table here, so that instead of using like one of those little alligator clips, that you can get, I just use a vice clamp and make sure there's absolutely no chance this thing is going to move at all. That's it. Now I'm going to try to put this thing back together. Really not much else to say here. Wish me luck. One thing I'm going to do is, I don't know what's going on, but sort of the secret shame of this gun right now is that I will, at some points, sometimes when I plug in a battery, it starts smoking. I'm not really sure what that's about, but that always makes me start swearing and deactivate the battery or disconnect the battery, and but it still works, So one thing about the button pad that I learned is that, let's see if it starts smoking. This will be fun. Nope. Looks good. Nothing's catching on fire. One thing is that when you have the button pad, you can either use the button pad or you can use the physical button on the board, but you can't use both. If you use one, the other one won't work. So in this case, something to note is that for these Lucky Ion boards, for some reason, the physical button on there is placed such that it was not working with this Epiphany button. I was using it briefly or previously with a standard, I had a Virtue rubber button that I was using, which makes it hard to see that the gun's on or not. So I actually prefer using these plastic buttons because you can see the light and what color it is. But yeah, you have to be careful also because when you got these plastic buttons installed, at one point I broke off the little LED on here and I was able to somehow by some miracle solder it back on with a very small bit of solder. All right, well, I'm going to go ahead and sign off. I'm gonna go put some, whatchamacallit, some waterproofing on here. Hopefully they'll take care of the whatever is shorting out and causing it to smoke. And yep, done.